Friends, welcome to my YouTube channel. Dhanesh here. In the last video, we were discussing about a practical example for one-way ANOVA. In this video, I am going to discuss a practical example for two-way ANOVA. Let's start. This is a quote from Socrates: "An unexamined life is not worth living." Let's continue with two-way ANOVA practical example. This is the complete equation. You need to understand about ANOVA. ANOVA is equal to variability within the means divided by variability within the distribution. It's a simple equation we have discussed even in the previous videos. Actually, this is the fifth video on ANOVA. Then you know about the different types of ANOVA: one-way ANOVA, two-way ANOVA. See, what's the difference? Even in the last video we discussed, just I am giving an idea. A two-way ANOVA is designed to assess the interrelationship of two independent variables. Very important, on a dependent variable. A one-way ANOVA only involves one factor or independent variable, whereas there are two independent variables in a two-way ANOVA. A one-way ANOVA is a type of statistical test that compares the variance in the group means within a sample while considering only one independent variable or factor. That's about one-way ANOVA. You know it. Fine. Let's take our practical example. This is a two-way ANOVA example. It is classified according to two criteria, that is, two independent variables are coming into picture. Here the data gives the study hours of four students. PQRS, they are the students. PQRS for different days, that is Monday, Tuesday and Wednesday. These are all the study hours, 2, 3, 4, 5. You got it. So here we have two independent variables. One is the students, and PQRS are the students, and Monday, Tuesday, Wednesday are another independent variable. They are the days. Two independent variables, days and students. Fine. So here two-way ANOVA can be applied, and variance can be calculated between the two independent variables, students and days, we discussed. So the null hypothesis and alternate hypothesis, that is the thing we need to first state. Null hypothesis: there is no significant difference in the studies between students, and there is no significant difference between the studies for different days. That is the null hypothesis. Alternate hypothesis is there is significant difference between the studies for different students, and there is significant difference between studies for different days. Yes. So step 1, grand total and correction factor. This is the first step of two-way ANOVA test. We need to calculate the grand total and correction factor. So let us take the mid value of the table as 5. From that we will calculate the other values. We are taking the mid value of the table as 5. Here you have the table and the mid value. This 5 is taking as a reference and we are calculating it. Then this value, it is 5 minus whatever it is there. It is, it is 2 minus 5. So in the table it's given it is 2. So this is 2 minus 5. So you will subtract all the values from this 5. Then if you see here in the next is 4. So you will get, when you subtract the 4 from 5, you will get minus 1. In this way you will get all these values by subtracting from 5. Then you will calculate the total. This is minus 3, minus 1 and 1. The total you calculated. Here the total you calculated. Here also you can calculate the total. Here also you can calculate the total. In the row ways also you can calculate the total. Minus 3, minus 2, minus 1. It is minus 6 when you calculate in the row wise. So here you can calculate in the row wise, it is 2, and here you can calculate it as 10. So here you will calculate the grand total. Grand total is 10 plus 2, 12 minus 6. When you calculate, this is the grand total. This is 6. So this is the grand total. This is the way. This is simple. We have taken the reference as 5. In this table the 5 is taken as the reference, and we are subtracting all values. 2 minus 5. 4 minus 5, 6 minus 5, 3 minus 5. Tuesday, this one will be 5 minus 5, it is 0. You can see the value here. Here it is 0. That's all. You got it. Now, correction factor, this is the formula for correction factor. This is the grand total square, the whole divided by observations. What is grand total here? 6. 6 square, it is 36. What is the number of observations here? In the table, you can see the first table total, it is 1 2 3 4 4 into again 8, 12 observations total. It is 12 observations. You can multiply row into column, you will get the total observations. So it is, we have taken as 12 and the correction factor is 4. Got it. Now the next is step 2, sum of squares between columns. So sum of squares between columns, you need to understand here. The formula is sum of squares between columns is p square by np plus q square by nq plus r square by nr plus t square by nt minus t square by n. What is p square by np? You can see here minus 3. You can see here this is minus 3. This is p, the total value is minus 3. That square, p square by np, you can see here it is, see, minus 3 the whole square by the number of times, the number of observations of p. The number of observations of p is, the student, p is 3. That is p square by np. That is minus 3 the whole square by 3. What is q square by nq? Q square is, the total q is 0. 0 square by number of observations for q, it is 3. In the same way, r square by nr, again 3 square by 3. Again you have, what is this, sorry, that is, t square by nt. What is t square here? See, PQRS. See here, PQRS, right? So PQ, this is not T, sorry, it's a mistake. This is yes for yes. That is a mistake. PQRS. Those are all the students, right? So there is a correction here. This is not T, this is S square by NT. What is S square? You can see here it as 6. So it is, you can write it as 6 square by 3 minus t square by n. What is t in the table? You can see the grand total is t. T is 6. This is the grand total is denoted by t and it is 6. And its square is, we have already calculated t square by n, that is 12. 36 by 12, which is 4. So you can calculate, it is t square by n. It is, we got it as, this is not 4, this is 3. This is a mistake. 36 by 12, it is 3. Sorry. 36 by 12, it is 3. That's what we put, here it as minus 3. So when you calculate this, you will get 15. You got it? So two corrections. Sorry for that. This is 36 by 12. It is 3. So that's why I put 3 here. And here this is not t. This is s square. The value of the student s. So that is, the student that is 6. So we have put here 6 square by 3. So step 2 you understood. Step 3 is sum of squares between rows. So between rows means the rows are for days. All right. The formula is Monday. M stands for Monday, T stands for Tuesday, and W stands for Wednesday. So M square by NM, T square by NT, W square by NW. Again, this is the, as we discussed, that is the correction factor. That is T square by N, it is 3. Here also we put it, this is 3 only. So what is M square by NM? M square, you can see here, see, it is minus 6. You can see from this table, this is for Monday, minus 6 square by the value. Here it is 2, here it is 10. These three values we need to take. So you will get it as minus 6 square by 4, then 2 square by 4 plus 10 square by 4. You can see here 4 is, because what is 4 there? 4 is the number of observations. See, in a day how many observations are coming here? 1 2 3 4. That's why Monday 4 observations are there. That's why we are putting it as 4. Here it is minus 6, 2 and 10. So it's correct. It is minus 6 square by 4, 2 square by 4, 10 square by 4. Correction factor is 3. So you will get 32. Fine, you got it. Step 4, it is total sum of squares. Total sum of squares. That is, total sum of squares means you need to square all the values and you need to subtract the correction factor. That is, total sum of squares means you need to come back to this table. See, this all these values minus 3, minus 1, 1, minus 2, 0, 2. See, all these values you need to take here and square it, and you need to subtract the correction factor. So it is minus 3 square plus minus 1 square plus 1 square. See, minus 3 square minus 1 square 1 square plus everything adding, minus 2 square plus 0 square plus 2 square minus 1 square plus 1 square plus 3 square plus 0 square plus 2 square plus 4 square. That's what I have written here. You can write, see here, minus 3 square plus minus 1 square plus 1 square plus minus 2 square plus 0 square plus 2 square, everything I am adding. After that, finally I am subtracting the correction factor. When you calculate this, you will get the 47. You will get the value as 47. You understood? Total sum of squares means, once again I am repeating, you need to calculate all the values in this table. See, this is minus 3 in the first column. You don't take the total values. You don't take the total values. Only the first column, that is minus 3, minus 1, 1. Square it and add it. Minus 2, 0, 2. Second column. Square it and add it. Minus 1, 1, 3. Square it and add it. 0, 2, 4. Square it and add it. You won't take the total values. This you won't take. This total also you won't take it. So that minus the correction factor. That's what we are getting it in this here. You will get it as 47. Total sum of squares. You got it. Now step 5. Total sum of squares due to errors. See, this is the formula. So total sum of squares due to errors is equal to total sum of squares minus minus of sum of squares between columns plus sum of squares between rows. That is 47 minus of 15 plus 32. This is 32. This is 15. So 47 minus of 15 plus 32, that is 0. You will get it as 0. Got it. Now, this is the table for the two-way ANOVA. So this table will completely explain you. So you have the source of variance, you have between columns, between rows, and residual errors also we put it. See, sum of squares here, degree of freedom is here, mean sum of squares is sum of squares divided by degree of freedom. F ratio is mean sum of squares divided by residual errors. You will get it here. See, now you understood sum of squares between columns, it is 15. You put it here. You put it in the table. This is 15. Between rows, you got it as 32. See, I can show you here. This is 32 between rows. And you got the residual errors. See, this you got it as the total sum of squares due to errors. This is known as the residual or error. Residual or error. So you got it. That is, you put it here, it is 0. You got all those values 15, 32, and 0. 15, 32, and 0. You got it. Now you have the degree of freedom. See, I have a separate video on degree of freedom. I have, for different tests, ANOVA, T test, Z test, what is the degree? Everything is explained there. You can watch that video. Degree of freedom, for between columns, it is Z minus 1. Between rows, it is R minus 1. For residual errors, you need to multiply both, because both rows and columns here. So Z minus 1, R minus 1, C minus 1 into R minus 1, it is 6. So Z minus 1, we have, 4 columns. So 4 minus 1, 3. We have 3 rows, that is 3 minus 1, 2. When you multiply it, 3 into 2, 6. You got it. Mean sum of squares is sum of squares divided by degree of freedom. That is 15. This is 15 divided by 3, that is 5. This is 32 divided by 2, that is 16. This is, sum of 0 divided by 6, that is 0. You got it. Now, F ratio, this is the calculated F ratio. We will get it from the table as well. Calculated F ratio is mean sum of squares divided by residual errors. See, what is the mean sum of squares here? It is 5. So 5 by 0, the residual error is 0. 5 by 0, infinity. This is the calculated F ratio. Here it is again 16 by 0, infinity. You got it. See, even you have the total sum of squares, that is 15 plus 32, you got it as 47. I have written here. Total degree of freedom, when you add all this, you will get it as 11. Total degree of freedom, it is 11. You got it. 6 plus 2 plus 3. That's also there. So you got the F ratio. That is the key point. Calculated F ratio we have. Now we have the table. This is the table for, for a significance level of 0.05 or 5 percentage. We are more interested into the 5 percentage. You can watch the video for significance level. 5 percentage or 0.05 is the significance level we look for, right? So this is the table for a significant level of 5 percentage or 0.05. So we will look at the columns. See, between columns we need to take the value of, degree of freedom as 6 and 3. See, here you have the residual errors, degree of freedom is 6, and for between columns you need to 6 and 3, this combination you can take. So for 6 and 3 you will get it as 6 and 3, you will get a calculated value of 4.76. So F calculated for 6 and 3, it is 4.676. Then between rows there is 6 and 2. 6 and 2 you will get it as, 6 and 2, it is 5.14. You got it from the table. So you got it 5.14. This tabulated value you got it, and you got the calculated value, both are infinity. Calculated value, both are infinity. From this, both F calculated in both the cases. See, both the cases means you have two cases. This is the F calculated. These two are infinity between columns and between rows. So F calculated in both the cases, F tabulated in both the cases. F tabulated you have between columns and between rows for students and days. So both of them are F calculated is greater than F tabulated, because F calculated we got it as infinity and F calculated is greater than F tabulated in both the cases. Hence we need to reject the null hypothesis and accept the alternate hypothesis. That means there is significant difference between the studies for different students, and there is significant difference between the studies for different days. For different days and different students, there is difference. So this is the, Anova two-way Anova test, because we have two independent variables, students and days. So that's all. Thanks for watching. Please like, share and subscribe. Thanks a lot.